Hello everybody. Today we're going to look at graphing our parent functions, or the most basic versions for sine and cosine. So that would mean like without any transformations. So what we have here is our unit circle. And for those of you who are unfamiliar, the unit circle is essentially a circle with radius 1. And at all of these little segments that you see going off here, those would be at some key angles that we deal with a lot in trigonometry. The first one represents an angle of rotation of 30 degrees, and then the second one would be 45, third 60, and then to 90, 120, 135, etc., all the way around with a lot of those angles that we've been working with before. If you'd like to take a moment to pause the video and fill in your worksheet with all of the coordinates of the unit circle going around, and also to fill in the values for sine at all of those angle measures right here. Good thing to remember is that when we are finding the value for sine at any of these coordinates, that it is always the y value on the graph. So you'll notice that at 0 degrees the y value is 0. At 30 degrees the y value is 1/2. At 45, root 2 over 2, etc., all the way around the circle. Alright, now that you've got those filled in, what we're going to do above this is we're going to find the approximation for all of these values that we have. And for a lot of these, there's really not anything we need to do. Like 0 is already exact, so that'll be 0. Same with 1/2. If it's helpful to put it in decimal form, we'll do that. But the next one that we need to approximate is root 2 over 2. And that is going to be approximately 0.707. So I'm just going to round that to one decimal spot. I'm going to put that to a 0.7. And then for 60 degrees, we will approximate root 3 over 2. And that is approximately 0.866. So I'm going to approximate that at about, let's just round that to a 0.9. Now remember, these are rounded approximations. At 1, I don't need to do anything there. And now all of these values are essentially just going to repeat. So at my root 3 over 2, back down to 0.9, root 2 over 2, back to 0.7, over here, 0.5, and then 0. And now I'm going to have those same values again down here, but they will be negative. So a negative 0.5, a negative 0.7, negative 0.9, negative 1, negative 0.9, negative 0.7, negative 0.5, and finally back to 0. So now that I have all of my coordinates, I'm going to take all of these and plot them on my graph. Excuse me. So you'll notice that along my x-axis, I'm going by degrees. And each little tick mark represents 30 degrees. So for our 45 degree multiples, like 45, 135, etc., we'll need to just put those right in the middle. All right, everything else will fall on the grid, but we'll be aware of those. So my first point is going to start at 0, 0. It's going to start at my origin right here. And then the next one is at 30 for the x value, and 0.5. Our next one, 45 degrees, so this will be right in the middle. All right, don't go all the way to the next grid mark, but it'll be at 45 and 0.7. So right here at this line, this is going to be approximately 0.75, right between 0.5 and 1. So I'm going to put it just below that line right there. And then my next one at 60 degrees is at 0.9. So at 60 degrees, I am just beneath the line right there. And then at 90 degrees, I'm going to be at 1. Now, at 120 degrees, I'm back down to 0.9. So just go a little bit below it. At 135, so this will be in the middle. All right, don't go to the next tick mark on the x-axis. But at 135, I am at 0.7 again. And you'll notice that these heights will start to repeat themselves, so we can just reference back to the other one. At 150, I'm at 1/2, or 0.5, and then at 180, I'm back down to 0. Now for these next values, I'm going to start going beneath the x-axis. So at 210, My next tick mark here, I'm down at negative 1/2. At 225, that would be in between 210 and 240. I'm at negative 0.7. So this time a little bit above that line, all right, which would be negative 0.75. At 240, I'm at negative 0.9, a little bit below that final line there. And at 270, I am at negative 1, all the way down. 300, negative 0.9. At 315, so in between these, I'm at negative 0.7. And again, you can just look back to the other one that you've done and make those the same. At 330, I am at negative 1/2. And finally, at 360, I am at 0. So now let's go ahead and connect all of these points with a nice curved arc. And it's almost going to be like a sine, or a wave, which is what we refer this to. This would be called a sinusoidal wave. And so a couple of things that I'd like to talk about at this point. I am graphing one period of this graph starting at 0 and ending at 360. Because at this point, the graph would keep going up this way if I were to graph more points. But we call this one period because at 360 degrees, once I pass that, the graph starts to repeat itself. And it will continue to make this exact path over and over and over again as I keep going up or to the right. And likewise, if I were to keep graphing to the left, it would start repeating itself the same way. It would continue to go like this, and it would follow that motion. All right. On the other page, we're going to take a look at graphing a little bit more than one period of our graph. Okay. Now let's head on down and let's take a look at the basic shape of cosine. So cosine is going to be our x values from the unit circle. And so now if you'd like to pause the video, let's take a moment to fill in those exact and approximate values. All right, so again, if you need to pause the video now, go ahead and do that and make sure that you've got all of your coordinates matching what I have here. So now let's go ahead and start plotting these. You'll notice the difference between sine and cosine is that you always want to think sine starts at 0 on your y-axis, or at the origin, and cosine will start at 0, 1. So at 0 degrees, I already have that value of 1. And then from there, we will start to go down. So they're going to look similar, just slightly shifted, in fact. So at 30 degrees, I go to 0.9, slightly below. At 45, again, in the middle of those two, I go to 0.7. At 60 degrees, I'm at 0.5. At 90 degrees, I'm down at my axis at 0. And then at 120, I start to go negative. So I have a negative 0.5. At 135, in between these two, I have a negative 0.7. So just a little bit above that line right there. At 150, I have a negative 0.9. And at 180, I'm down at negative 1. At 210, I'm at negative 0.9. And again, you can just kind of look over to your left and match it up horizontally. At 225, so in between these two, I'm at a negative 0.7. At 240, I'm at negative 0.5. And at 270, back to the axis at 0. At 300, 0.5. At 315, so in between these two, I'm at 0.7. And if I'm graphing too fast at any time, feel free to pause and, catch up. At 330, 0.9. And at 360, positive 1. Now I'll go ahead and connect these with a nice smooth curve. All right, and if I could just critique myself right here, this portion of it got a little bit, it's almost a little bit straight, a little bit of an inaccuracy right there. It should have more of a downhill shape. And then as you get to the bottom part, it should look like a bowl. The technical term, we say concave up and concave down. But here we see 1 period of our cosine function now in the first period. So you'll notice that these are very, very similar. In fact, it is the same exact shape. The only difference is that they are shifted slightly. If I were to pick up this piece and move it along with this entire graph up to this point right here at 90 degrees for sine, there would be a perfect overlap of these two functions and these two graphs. Alright, so go ahead and flip it over to the back side now. We're going to take a look at graphing these same two functions and a little bit more of an aspect of what your homework will be. So we did a ridiculous amount of points to graph these two functions to get a very nice and exact shape. A lot of times when we graph trig functions, we're really just going to have 5 main points so that we get 1 full period of the graph. So I'd like you to fill out your axes like you see them here. Go by 90s for all of your x values. And let's make the top and bottom of each of these 1 and -1, and halfway will be 0.5 and -0.5. So you'll notice that as I start with sine, I'm going to start at 0, 0. And then my next critical or key point that I'm going to make at 90 degrees is going to be all the way up at 1. And then at 180 for sine, I'm back at 0. And at 270, that's when sine went down to -1. At 360, back up to 0. And if I were to go 90 more degrees, this pattern would repeat itself. You know, if you were to, before I fill in the line, imagine the wave of this sine. So at 450, I'm back up to 1. And now I'm going to continue this wave downward over here to the left at -90. I would be back down to -1. Next 90 degree interval, I'm back to my axis. And now if I connect these with a nice smooth curve, we got a little sloppy there at the end. Turned into more of a line over here. And you know what? I'm just going to go over this, make it better. That's what it should have looked like right there. But here you now see more than just 1 period of this sine function. 1 period would, again, be between my hands here and here. And I would maybe call this the first period because it's right from the axis. But I could also say, you know, if I look at this part of it, that that's also 1 period just from different x values. Maybe I take it from, you know, top to top right here, and there's 1 period of my graph. Okay. Now let's go ahead and why don't you try to do the same on your own for cosine. And again, I'm just pulling all of these main values from all my 90 degree intervals from right here. And there are also, you know, values where at this time we should have a decent amount of those memorized. Alright, so I've got my main points here for cosine, and you'll notice that it's essentially the same pattern again. This time I'm just starting at 1 at my y-axis. And so then I'm going down, next 90 degrees to 0, to -1, back to 0, +1, down to 0. And so it really becomes quite an easy pattern that will just keep on repeating itself. So I will connect this with a nice curve here, to the best of my ability. And another thing that you'll notice, like for all extensive purposes, this is going to be accurate enough, but you'll notice that the shape of this is far less superior to when I graphed more points, you know, which is always the case. More points, more accuracy. So one thing for us to just kind of take out of this is that, you know, as we're doing these functions, remember that they're basically the same shape with a slight horizontal shift to them. One last thing to add, please make sure that you always do end your graphs with arrows because they will continue forever and ever and ever. This is an infinite cycle because theoretically, you know, we could keep going up to -infinity degrees and +infinity degrees. And also, for all of you Huntley High School students, for all of this like A, B, C, D stuff, don't worry about that. When we start to get into our homework assignments, it'll make a lot more sense. Thank you, everybody.